Yeah. So welcome back, students, to this eighth lecture on laws of motion. So in this lecture, I will just try to tell you a very important thing, that how exactly do we calculate this, or what is basically a normal reaction, right? So in order to understand friction, which we had started discussing in the last lecture, okay, it's important that we understand this very important thing, which is called as the normal reaction. And how do we practically calculate it? That's what we will just learn here. So normal reaction, as you can see, it's a force which is perpendicular to the surface, and whenever an object is in a flat surface, the normal reaction N, which you can see here in the diagram, is always equal to the weight in a flat surface under gravity. Okay, so as you can see here, normal reaction uh, will be acting upwards. It's like an action reaction pair as per Newton's third law, and normal reaction will be equal to the weight. Let us take an example. Okay, so if I take an example of an object, right? Let us say I have an object which is on the surface, right? And this object has a mass of 25 kgs. Okay, so the mass of the object is 25 kgs. That is the mass of the object. Okay, now if I ask you the question, how are you going to find the normal reaction? Okay, so as you can see in the diagram here, the normal reaction will be equal to the weight. Okay, now coming back to this diagram over here, so the weight will be acting downwards, and equal and opposite force because of this surface over here. Okay, so if I just show you this surface, that this surface is, so whenever you keep, say for example, you keep a 25 object on a table, then there will be a normal reaction which will be acting in which direction? Upward direction. Now this normal reaction will be equal to the weight. Okay, so if I have to calculate this weight over here, so weight W is equal to m into g. Always weight is mass into acceleration due to gravity. So that will be 25 into 9.8. Okay, so the weight W is going to be in our example. Okay, so if I just take a simple calculation, say 9.8 into 25, that gives out, so 245 Newton. That is the weight which I'll get. So normal reaction will be equal to weight, and weight is equal to 245 Newton here. So I can say normal reaction is 245 Newton. Okay, so this is how we basically we calculate what is called as normal reaction, right? Let me take one more example so that you are more clear with this particular concept here. Okay, let us say I ask you, calculate normal reaction for object at rest, okay, on a surface. Okay, now let us say for example, this object has a mass of 60 kgs. So what will be its normal reaction? So the weight mg will be acting in downward direction. The normal reaction n will be in which direction? Upward direction. Okay, so if I just calculate this normal reaction n, which we call it as normal reaction, okay, that will be equal to the weight W, okay, and that is equal to mg. So I'll have to multiply 60 with 9.8, which is acceleration due to gravity, and I'll get this normal reaction as, so if I take a simple calculation here, you will get 60 into 9.8, and that value is 588 Newton. Okay, so normal reaction will be equal to the weight when the object is in a As you can see in the diagram, if the object is at rest and kept on a surface, that time normal reaction will be equal to which one? Weight. Okay. Now, if I have an object which is slanted like this, okay. Now this object is it's in an inclined plane, okay. And if you can see the inclination over here, okay, it is the object is kept in a slant plane, okay. Now in a slant plane, as you can see in the diagram, okay, here the normal reaction is n, as you can see in this diagram. So if the inclination is theta, the normal reaction n will be equal to mg cos theta. Okay, the normal reaction as per our diagram, this diagram, n is equal to which one? Mg cos theta. Okay, so in an inclined plane, right? So very important I want to make you to understand here is that the object's downward force will be mg sin theta, but the normal reaction in an inclined plane, when an object is at an inclination, that normal reaction will be equal to mg cos theta. Okay, so I can say that a very important thing I can discuss over here or say is that in an inclined plane, okay, the normal reaction is n equal to mg cos theta. Okay, the vertical value n, as per this diagram which you can see, this n is the normal reaction. It will not be equal to mg, it will not be equal to mg sin theta, it will be equal to mg cos theta, so that the objects are at which one, so that is how we calculate normal reaction in an inclined plane. Okay, so let us take an example that, say I have an inclined plane, okay, say this is an okay, I'll just say, yeah, so this is an inclined plane, as you can see in the diagram, okay, and here I have an object, okay, and I ask you this question that if this inclination angle theta, okay, so here if theta is say 60 degrees, hmm, and this object say has a mass 25 kg, then what is its normal reaction? Okay, will the normal reaction, can we calculate the normal reaction as we did earlier? No, we cannot calculate, because now actually the normal reaction has to be calculated like this. So basically what happens is the weight mg will always act vertically downwards. This is the very important thing about or the facts about physics, that the weight mg will always be acting downwards. Then you have this force here, then another force which is here, and exactly opposite to this you have the third force here. Okay, so now what basically happens is this angle also is 60 degrees. So you have mg cos 60 degree here, mg sin 60 degree here, and the normal reaction is n, which is in which direction? Upward direction. Okay, so the normal reaction in an inclined plane will be mg cos of 60 degrees. Now the mass of the object, okay, we said that the mass of the object is 25 kgs, the acceleration due to gravity is 9.8, cos of 60 degree is 1 by 2, that is the value of cos 60 degrees. Okay, so if I now want to calculate normal reaction n, that will be equal to 25 into 9.8 into half, which is cos 60 degree, mg cos 60 degree. And when you do this particular calculation, okay, you will get the value that is 25 say into 9.8 in or divided by 2, you will get 1225. Okay, so just a second. Yeah. So this value, it comes out to be 122.5 Newton. Okay. So the normal reaction in an inclined plane is 122.5 Newton. That is how we can calculate. Let us take one more calculation. Okay. Let us say I ask you this question that you have an object which is in an inclined plane. Okay. So this is the object in an inclined plane, right? And then here you have this particular object. Okay. Then question is calculate the normal reaction. Okay. So we have to calculate this normal reaction over here. What is the normal reaction? Given mass of the object is say 50 kgs and the angle here is say 45 degrees. Okay. So I'll give you 1 minute. Like, can you try this? In an inclined plane, what will be the normal reaction? Okay. So if you would have tried it, you would have seen that the normal reaction N will be equal to mg cos 45 degrees, which is 50 into 9.8 into cos 45 degrees 0.7071. That's what is the value you will get. Okay. And when you calculate this thing, okay, so you will get 50 into 9.8 into 0.7071. Okay, and that value comes out to be 346.4 something, maybe Newton, right? So this will be the normal reaction when the object is basically at which one? In an inclined plane at an angle of which one? 45 degrees. Okay. So two examples I gave you when we had these flat surfaces over here. Okay, like when a surface is flat, that time normal reaction will be equal to mg, which is equal to the weight. Okay, and when the surface is at an angle theta, that time you can see the normal reaction is mg cos theta n equal to mg cos theta, and you'll get this particular surface. Okay, 346. Now, the next important thing is that why is this normal reaction so important for the discussion? Okay, so here I'll just come to the next important point here, that once we saw what is called a normal reaction in a flat surface, okay, we saw normal reaction in an inclined surface, right? So we have what is called as laws of static friction. Okay, so what it basically says is that first thing is that like whenever an object is at rest, there will be a frictional force. Okay, and if you apply Newton's law, okay, Newton's law will directly tell that at the moment you apply force on an object, it should move. But if you try to apply a small force on a table which is at rest, that table doesn't move. The reason is that the frictional force is holding the table. So you have to apply a force which is more than the frictional force. Okay. So the laws of static friction, what they say is that the frictional force depends on the nature of surface, like whether the surface is rough or the surface is polished one. Okay. Second is it is independent of the area of contact. And third thing is that very important thing is frictional force is directly proportional to the normal reaction. And that's what I discussed in this topic, that frictional force is directly proportional to the normal reaction. Okay. And now if I come back to the theoretical part of this, okay, that I just want to, maybe I'll just discuss this very important thing, which I will call it as coefficient of static friction. Okay, so coefficient of static friction is, we know that I am telling Fs is the frictional force. Okay, basically what I am telling here is Fs is a frictional force, it is directly proportional to the normal reaction. That is the very important law which we are basically discussing. Okay, so frictional force is directly proportional to the normal reaction. Okay, or Fs is equal to mu s into n. Okay, and this mu s which I am discussing over here is called as the coefficient. Okay, this is basically called as the coefficient of static friction. Okay, and this coefficient tells us exactly what will be the frictional force I'll have to overcome in order to get the values. Okay, so let me take an example. Okay, like let us say I have a rough surface. Okay, and this rough surface, this example will tell you like what exactly I'm trying to make you people understand. Say this is a rough surface, and on this rough surface you have coefficient of static friction is 0.3. It's a ratio. Okay, this value is like between tire and road it will have a different value. Okay, between table and the floor it will have a different value, so it depends. Let us say for example between the object and the this particular surface the coefficient value is 0.3, right? We know, or the important thing which I would like to tell you here is that the frictional force Fs directly depends on the normal reaction. So frictional force is equal to mu s into n. So we have introduced a constant here. This constant is known as which one? Coefficient of static friction, right? Now my intention is to calculate what is the value of this static friction, or how much will be the frictional force, or how much force I will have to apply in order to just move this particular object. Let us say the object has mass is 30 kg. Okay. My question to you is, can we calculate somehow how much minimum force I have to apply on this object? Minimum force I have to apply on this object so that the object moves. You will see that if I apply any small value, the object is not going to move because your force should be equal to or more than the frictional force, right? So in that case I will have to find the frictional force which is actually acting in which direction? Fs. So normally F we call it as the applied force. Okay, we normally call F as which one? The applied force, and Fs is the frictional force. So if I have the minimum force, so my question is what is the minimum force? Okay, what is the minimum force to move the object? Just I have to move the object, how much force is required? Because there is a friction, you can any force is not going to move the object. Okay, so the calculations how we do here is we first find, okay, we basically find what is called as the frictional force first. Okay, in order to do this what I'm trying to do is I'll the minimum force required. Okay, the minimum force required should be greater than, if it is equal to the object is in a state of equilibrium, at least it should be greater than the frictional force. So how much is the frictional force? We calculate it by mu s into n. Okay. Now we know that mu s into m into g. The normal reaction is given by which formula? M into g. Okay. So now if I do the calculation, what are the values? Let us see. As per our question, the value of mu s is 0.3. Okay. The value of mass is I have taken the mass of the object is 30 kgs. The value of g is 9.8. Okay, so the frictional force acting, which is a static frictional force, that when the object is at rest there is a static frictional force acting, so that static frictional force will become 0.3 into 30 into 9.8 by using the formula Fs is equal to mu s mg. So here mu s, this s here It basically denotes static friction. Okay, so now if I do the calculation, how will the calculation basically look? The values, if you calculate it, so zero point 0.3 into 30 into 9.8. So the value will be 88.2 newtons. Okay. So the minimum force which I have to apply in order to just move the object will be 88.2 newtons. So below 88.2 newtons, this object is not going to move. Okay. It will just start moving if the force is above which one? 88.2 newtons. Okay. Let us take one more example. Okay. Say same type of question. Okay. So the question, let us say I'll ask is, uh, what is the minimum force to move an object of mass? Okay, let us take the mass 50 kg on a surface having mu s as 0.4. Okay, and the value of g we will take it is 9.8 meters per second square. Okay, so this is the question. What is the minimum force to move an object of mass 50 kg on a surface having mu s equal to 0.4? Normally it will not have any unit. Okay, and the value of g is 9.8. So now if I just try to solve this particular question, okay, so I'll just give you 1 minute. Can you calculate what will be the value? You can just pause the video at this point and then calculate the value, and just let us compare your calculation with mine. Yeah, okay. So normally we are talking about a situation where you have kept a 50 kg object and it's on a rough surface. Okay, we have a 50 kg object which is on a rough surface. Okay, and I'm trying to find the minimum force required to move it. Okay, so the minimum force that must be equal to the frictional force which is not allowing it to move it. So basically I have to calculate Fs. Okay, so Fs will be equal to mu s, coefficient of friction, into the normal reaction, right? So you will get the value as mu s m into g. Okay, so the value of mu s is 0.4, mass of the object is 50 kgs, and acceleration due to gravity is 9.8. Okay, and from this calculation we get the value as, say, zero point 0.4, I multiply it by 50, I multiply it by, say, 9.8, I'll get the value 196. That is 196 Newton. Okay, so the coefficient of static friction is which one? 196 Newton. Okay, so in today's lecture, we saw how a problem has to be attempted and how is this frictional force related to this normal reaction. So the basic laws of friction, it states that the frictional force is directly proportional to the normal reaction. So please see this video and do the assignment which will be based on this particular calculation of normal reactions and calculation of frictional force. Okay, and then in the next lecture we'll see how the calculation for different situations can be taken up. Okay. Thank you.